All right, here in 4.3, chapter 4, we're going to look at some quadratic functions. And, you've heard this term a lot from me, but your quadratic function is quadratic because of that second power. And so you're going to have functions that have more than just x squared plus or minus a number. They're going to be a little bit different to graph than what we did in the transformations in 3.5. But this is how we're going to do it. These are the items we want to identify for your quadratic functions. Whether it opens up or down. So when we talk about opening up, it's either going to be a U shape like that. Opening down is going to look something like that. The vertex. We have a way to find the vertex. So again, we're going to be looking at, let me try some of these settings here. We're going to be looking at the x coordinate can be found by minus b over 2a. Your y coordinate means you substitute that value you just got for the x coordinate into the equation to find the y. But your vertex itself is this highest or lowest point on the graph. So that's your vertex right there. Okay, it's that 0, 0 point of where we started when we did the transformations. Okay, so think about that is the important point to find, is the vertex. We can also find your x-intercepts. So again, we set the equation equal to 0 and solve for x. We also want to find the y-intercept. And we also want to find the maximum or minimum value. So when we think in terms of maximum value, the parabola is going to open downward. So we have a max value if it opens downward. And again, it all involves the coordinates of the vertex. If the parabola opens up, we have a minimum value. So, we're going to go over all these, but this is what you need to identify for me from the quadratic functions. Okay, so let's move on then, and let's look at graphing and identifying these items we're talking about. Okay, so if I look at this equation right here, x squared plus 2x minus 3. This is the quadratic function itself. First, I want to know, does it open up or down? And what I know is, first thing, opens up. A is positive, okay? Because A, in this case, is 1. We also know that B is 2 and C is negative 3. So I know it opens up. So looking at, my two sketches up here, we know therefore it's going to have a minimum value. The second thing we want to identify is the vertex. Now this is, kind of confusing at times, but you've got a formula. So keep in mind your x coordinate is minus b over 2a. Well, I know b is 2, so I make that negative 2. A is 1 over 2 times 1, which negative 2 over 2 gives me negative 1. My y-coordinate is f of negative 1. So I take this x value here, substitute it into the equation, and simplify. Okay, so just watch your signs, make sure you do all this correctly. But when I get my answer, I get +1 minus 2, I get -4. So I then know my vertex is -1, -4. Your vertex has to have an X and a Y just like every other point on the graph, and you got to make sure you understand how to find it. The third thing are my x-intercepts. So what I'm going to do is I'm going to solve x squared plus 2x minus 3 equals 0. So I got a factor. So I set up my two parentheses, put in my x. Now I need factors of -3 with a difference of +2. So that would be +3 and -1. And don't forget, your solutions are going to be x is -3 and x is +1. So your x-intercepts are -3, 0 and +1, 0. My y-intercept, well, that is f of 0, which is 0 squared plus 2 times 0 minus 3, which is just -3. So your y-intercept is 0, -3. Now what I'm going to do is I'm going to go ahead and just plot to graph. And I know I'm running over into the other example. I'm going to do it on the back page. So to graph, I want to plot the vertex, which is -1, -4. My x-intercepts, which are -3, 0, 1, 0. And then thirdly, my y-intercept, which is 0, -3. So for just about every parabola we graph, we're going to have, I should say most of the time, but just about every time, we're going to have 4 points to plot. Sometimes you won't have x-intercepts, as we'll see here shortly, but most of the time you will. So I'm going to go ahead and I'm going to sketch over this graph here that didn't print very well. 1, 2, 3, 4, 1, 2, 3, -4. So I got 4 here, got -4 here. 1, 2, 3, 4, -5 here. +5 here. That's my x and that's my y. So I plot my -1, -4, which takes me about to there. My 0, -3, which is my y-intercept. And then my x-intercepts of -3, 0, and +1, 0. And then I just go ahead and make my sketch. Okay. So that's how, one way or the way to graph it. We've answered the first 4 questions. Now the 5th one was, we can see here, we didn't know, is the maximum or minimum value. and your maximum or minimum, just think about what we just did on the test. We had local maximum, local minimum. It's right here. Since it's a parabola, it only has one max or one min. So your max value is your y coordinate of your vertex, or the minimum value, depending on which one you have. So in this case, we have a minimum. So my minimum value is y equals -4. Okay. So that's one example. All right, that's an example where, we opened up, we found our intercepts, we found the vertex, and so on. Now we're going to look at the second example. Again, I'm going to flip this page over to the back, as there's nowhere near enough room. So let's look at f of x is -2x squared plus 4x minus 5. Okay. So, step 1, I know it opens down. A is negative. And what I know is A is -2, B is 4, C is -5. Second thing, I want to find my vertex. So remember, your x coordinate is -b over 2a. Substituting, -4 over 2 times -2. And that gives me -4 over -4, which is +1. So again, that is my x coordinate. Don't make a mistake and just automatically throw 0 in there for y. It doesn't work that way. Once you know x, you always think of your table of values. Okay? Always think of your table of values. And you can even keep track of your points that way if you want to. Now, your y coordinate is f of 1. So f of 1 so remember, square the 1 first, then multiply it by -2. If I do all that, I get -2 plus 4 minus 5, which is -3. So f of 1 is -3. So again, you can keep track of your points. Okay, there just seems to be such a confusion with graphing, and just always keep in mind that it's just x's and y's. There's just different ways to find x's and y's. But there's your vertex for you. Okay, so just, keep track of them however you want to do it. You can do it like this. You can keep a list of coordinates by putting them in point form, whatever you want to do. Whatever's easier for you to understand what to do next is fine. All right, so that's your vertex. So again, that's always one of the more difficult things. Third thing, x-intercepts. So I want to solve -2x squared plus 4x minus 5 equals 0. Put it up so you can see that. This can't be factored. The way I know that is I take negative 2 times negative 5 gives me 10. Well, there are no factors of 10 with a sum or difference of 4. So therefore, I know I can't factor this, so we're going to have to use the quadratic formula. So minus b plus or minus the square root of b squared minus 4ac all over 2a. Now I'm going to substitute. So minus 4 plus or minus 4 squared minus, be careful here, 4 times a times c. So you've got to watch your signs here. All over 2 times a. Very careful with your signs. That's why it's better, learn how to do this on your calculator. Don't worry about the square root. Just figure out what's under the square root. So what I end up getting is negative 4 plus or minus, well, this is 16 minus 40, which is negative 24 over negative 4. So at this point, since we have a negative under the square root, there is no real solution. Therefore, there are no x-intercepts. Doesn't mean you can't graph it. It just means it's not going to cross the x-axis. And some of y'all may already be ahead of me thinking, well, the vertex, if you think about where we plotted the vertex, 1, negative 3, well, that's below the x-axis. And since it opens down, there's no way we can have x-intercepts, okay? But we can still graph it. So the last thing is the next to last thing is the y-intercept. And hopefully you've kind of seen the deal with that. For this particular equation, it's whatever c is. For any quadratic, it's whatever c is. Because when you put zeros in for x, you're left with nothing but the negative 5. But we can certainly work it out. So again, you can list it as a point. If you want to keep track of your points, you can put it up here in your table, whatever you want to do. So in this case, we only truly have 2 points to plot. You can certainly find more, but we are making just sketches. So if I look at my grid here, 1, 2, 3, negative 4, 1, 2, 3, 4, 5, positive 1, 2, 3, 4, 5, negative 5. So think about plotting your 1, negative 3, right 1, down 3, about here, your y-intercept, and then you can certainly just make a sketch with those 2 points. That's all you need. So you don't need 4 points to graph it. Just sketch it, making it symmetrical. Also, identifying your maximum. So the fifth thing, your max value, since it does open down, is y is negative 3. It's the y coordinate of your vertex. Okay, so that's, 2 examples. One where we could factor to find the x-intercepts, where we had 2 x-intercepts. That was the first example. The second example, right here. Sorry about that. It opened downward. Couldn't factor. When we did use the quadratic formula, got a negative under a square root, which means no solution for the quadratic formula, no real solution, but it doesn't mean you can't graph it, okay? Just for time purposes, I'm not going to do another example. I will do another one in class. So we're just going to skip this one here, not worry about it. I'll work more in class, but I just want to look at the maximum and minimum values solely. Sometimes you are asked some form of finding maximum, minimum. Look for keywords, maximize, minimize. And it's just remember it's the y value of the vertex. So if you see anything to do with maximizing, minimizing, whatever, just find the vertex. And again, if it opens up, we have a minimum value. If the parabola opens down, we have a maximum value. So I want to find the maximum or minimum for this one. Well, what I know is it opens up. So we have a minimum value. Find the vertex. So remember, your x coordinate is minus b over 2a. So that's equal to, b is 4 here, a is 1. So that gives me negative 2. Your y coordinate is f of negative 2. And f of negative 2 is negative 2 squared plus 4 times negative 2. 4 minus 8. So it's negative 4. So since my vertex is negative 2, negative 4, my minimum value is y equals negative 4. Okay, and for quadratic equations that maybe you're missing a number, well, that means just C is 0 here. I mean, we're not graphing it, we're just finding the max or min, but your A is 1, your B is 4, and your C is 0. So just try to remember that. I see this missed all the time. Students aren't sure what to do when they see the word maximize or minimize or something like that. So, you know, just remember the keywords. Okay, and I'm not going to do this next example either, just because I'm trying to keep these videos at somewhat reasonable time frame, and I'll do more in class. So we'll cover these in class next time I see you. So that's it, quadratic. And again, you know, when you go to do your homework, which won't be tomorrow or whenever, just use the method we learned. You find what we did. Do it as I did it. Whatever I did here, you identify those items. And I'll remind you about that as well. So we will see you in class.